Software Engineering Junior, and I'll be on your moderating the chat.
Can we just start, I guess? I mean, everyone seems to be in. It's 12:06. Sounds about right.
So, welcome to the first workshop in the Explore ML series. Um, Explore ML is a 3 weekend long series where you learn start to scratch how to build your own machine learning models. So, from everything on how to get started with Python to how to create your own advanced ML models. Today we'll just be looking into intro to Python, and we'll just be going into some basics. So variables, control flows, function files, classes and objects. And we'll also start looking into some Python libraries. Today we'll look into Numpy, which is a popular data handling library, and we'll look into how to create our own data sets using Numpy. But before we actually get started into learning Python, we need to know why should we learn Python. So Python is one of the most simple and intuitive languages out there. It's really readable, and that's why a lot of developers prefer that. It's also a really versatile language. So you can use Python to code up anything. So anything from like machine learning models, you can do some data analytics stuff, you can create web apps. And as my job as an engineering analyst, I use Python daily to create some automation scripts and do some network security engineering. There's also a whole lot of extensive packages in Python, especially for machine learning and AI, which we'll be looking into more during the series. Um, Today we'll be using this tool by ACM development called Trackit, which we can use to track your progress. So you can go to trackit.acmutd.co, sign in and enter the code intro to Python, and you'll be coding along with us. And whenever you complete one step, you can click continue and we can go to the next step together. So I'll just give you like 5 minutes to get signed in into Trackit. So if you're having trouble creating a Google Colab file, I'm gonna walk you through that. So when you go to your drive, you can just click New, More, and Google Collaboratory. And this would just create a file in your home directory in Drive. And that should be it. And once you're done with that, you can click mark as completed on your on the track IT page.
Okay, guys, I think that everyone is ready now. If you guys still have problem, just leave it in the chat and our officer will help you guys. And I think we will start now with the fundamentals in Python. So I will share my screen now and we will walk through with this. Okay, you guys should see my screen now, right? Okay, cool. So let's get started. And if you guys, I will like put both of my check-it screen on the left and a Google Collab on the right so that I can keep track with you guys, like where you guys are working on. So on the first side, you should have like your computer working, internet, and your Google account logging into your Google Collab now. And okay, let's get started. Oh, next. Okay, so what do you need to know about Python? So Python is an interpret and object-oriented language. So it means that if you are familiar with C++ or Java, then you have to run like the compiler before you get your code run. It will not be the same in Python. It will just run straight away. And although the syntax error can be checked at the runtime, it's also a very high-level language. And it means that the syntax is very close to English. And different from other languages, the indentation or the spacing really matters in Python, which means that if you do like the wrong indentations, it will not run the code. It will show you some kind of errors. And Python is not really strongly typed, which means that when you declare a variable, like basically when you want to have like an integer x or something, you will not just put the data type there. You just type x and it will be defined dynamically. And we will get to know it better when we go along in the next slide, okay? And lastly, Python is case sensitive. Remember when you log into like the check-it, if you do it differently, intro to Python with like all the lowercase, it's gonna be different from intro to Python with the uppercase at the first, like the camels syntax. And for all the coding Python conventions, you could be referred to PHP 8 here. I have attached a link here, so yeah, you guys can look it up after the workshop to like get to know more like when should you guys like do the indentation, or there's some kind of specific rules for it to like make it easier for reading. All right, so let's get started with the console output and input. So we can see here is pretty much simple. I will open a new Google Collab here. Here is the table of contents of what we are going to walk through with the intro to Python. The first part, like the basic syntax, we'll get to know about the console input and output. We will talk about like variable and data type. Then we'll talk a little about the operators, what kind of operators you can use and how to use it. And then we will dive deeper into like some special structure type, the conditional and the loops, okay? So I will create a new Google Collab here so that I can work along with you guys. New notebook and just say, let's just put it here, intro to Python. And remember that you can always have it is very similar to a Jupyter Notebook if you guys already have experience with that, but it's not it's very easy. So it will allow you to like add the text and the code at the same time. Like you can just choose whatever you want. And the text will follow the markdown syntax. So like you can just like type, for example, like console output and input, so that it will disappear. It will appear, and just shift enter for it to load. Okay. If you are not familiar with markdown syntax, just like type the normal code like this one. It will be the same. Okay. All right, and then just other code there. And in our check-it slide, you should have the syntax to print out and to type input in there, and just copy and paste and put it here. So to print out something, to console something, to generate the output in the console, you just type print and then put the content of the text you want to type in there. And for the input, you just type input and then put the prompt inside of it. All right. And to run the code, you can just move your mouse to this one, this play button, and click play. The other option is shift enter. So for the input, it will give you like a prompt to say like, okay, it's Evelyn. And you can see when you want to mix between like a variable and a string, it will allow you to do it in two ways. The first one is just to put the comma there, and it will like automatically add for you a space like right after the string. Or the second way is use a plus sign, and there will no space automatically add. You have to do it yourself with the string. So yeah, I think we should be good for this. Is there any question for this? Okay, so we can like move on, right? So just mark it complete so that I can know that everyone is good with this, and move to the next one. Okay, we will talk more about variables and data types now. If you guys have already got some experience with programming language, this part should not like make you guys feel difficult or anything. But if you have no little experience, so very and not like familiar with the concept of variable, then just think about variables like a container of data. You want to assign some kind of values to it so it can store and use it later. And it's the difference in Python in compared with other languages that I said at the beginning, is that you don't need to specify what kind of values or data you want to store in that variable. For example, there will be like no integer x or float y, like in C++ or Java. You just type like x equal to 3, and it will automatically define at this time it's run. So just add another text here. Okay, let's say variable. And just copy and paste this one into the code block. You can see it immediately that the data type of the x is gonna be dynamically defined. And type parentheses x is the way for you, sorry, to print out like what data type of the variable is. So you can see that at the first, when you assign number 3 to x, it's gonna show as an integer. But then when you change the value to 3.0, it automatically change it to float. So for example, if you put like a string of 3 here, you will easily see it's a string. All right. There's 4 primitive data types in Python. It's string, is integer, float, and boolean. Okay. For string is like any kind of text that you have. Integer is just whole number. Float is any decimal number, and finally is boolean, is true or false. That's it. All right. I guess no question. Yeah, it's super weird when you do not like declare anything. Like when I first start with Python, I already like know about like C++ and Java, and I made the mistake to like declare a type all the time. And it's also like a kind of like a downside for this is like when you code like very long with like 1,000 lines of code, you must remember what type the variable is holding, because like it will not show, it will not have like a compiler to check it for you, or it will not like give you some sense of like what is working on. For some of the IDE, you can just move your mouse into that variable and it will like display like what kind of like data type it is holding. But most of the time you will need to remember like what do you did assign to it to avoid all kind of bugs when you move along. Okay, let's make this complete. And yep. Ugh, this one should. Oh no, I don't see the next one. Oh, where is the next one? Is this just me? Okay, let's try to. Okay, it's kind of weird. I think it's just kind of a glitch. Are you like good? Because like mine just got a glitch, and I want to make sure like everyone's good. Yeah, just click previous like me, and then it will like next, and it will move straight to like the next line. Just let me know in the chat if you guys are good, so I can continue. I don't want to like leave anyone behind. Okay, cool. So let's talk about operators. So this is very easy part. It's just similar to the way that you do math every day. It's just like plus and minus and multiply and then divisions. Okay, the only difference is that there'll be the mod one. It's very similar to other programming language actually. It's gonna be this percentage sign. And for the exponential, you would not want to use the hat one. This one will not work. I guarantee with you. I tried so many times. I just like use it like several times before I remember like, oh, it should be double stars. And the last one gonna be like the double slash. This one is one when you want to do like some integer divisions, like 5 double slash 3 is gonna give you the answer of 1 instead of 2, or 1.66, I think. In Python, is very careful when you use a division one, because even though you assign a values of integer at first, like x equal to 3 instead of x equal to 3.0, it still perform the divisions like the way you do math. So if you say 3 divide by 2, it will give you 1.5, not like 1 in other language. If you want to do the division, like integer division, you will need to do the double slash. But just remember, it's very close to the way you do math every single day. All right, you can just copy paste this in here and run. It will show you this one. All right. Okay, the next one is a comparison operators. Also, again, this one is very similar to other programming language and a daily math, just literally what it means. The only thing that you guys need to remember is equal to. This one is very common pitfall for everyone. Do not use one assignment operator, okay? It's double. It's 2 assignment operators. That means equal to. And here's a very simple math for you guys to do. I'm a very lazy person in doing math, so I just, I don't know, use Python to solve it for me. I don't want to calculate every single thing. So just let Python do it for me. All right. And yeah, if you say that you have the first variable, the second one, and then you perform the multiplication for the area 1, the area 2, and then you compare the area. All right. And the last one is the logical operators. This is what I love about Python. As I said before, it's very close to English, as I said, and it really is. Instead of using some kind of symbols to like interpret like is and or some kind of condition others, you just type exactly that word, okay? So for example, you can just say, if it's, here's a like a very simple one for you to follow. So in here, I kind of like import the random library so that it can generate for me a random integer number in the range between like -1000 and 1000. I don't know what the numbers is, so I want to check if it is between like 0 and 300. So it should be less than 300 and larger than 0. So I use the AND operator here to check if it is in the range, and it says false because the random number was like 569. All right. Any problem with this one? Okay, I don't see anything in the chat. So, yeah, we will move to that part right after all of this. I just want to make sure that everyone's got a good sense of the basic syntax, because like this one should be super easy for anyone who had already got some prior programming experience. But just please be mindful that there are some people joining this workshop with no or little experience. So I just want to make sure that everyone got a good sense of what we are doing here. I don't want people to just get lost and then just don't like really understand like why we are doing this and that. All right? Okay. How do you edit at all? What do you mean by edit? Like to put into the Collab. So if you want to like add a new code blocks or a text block, you can just see that there is 2 of the button here that you guys can just click and add. All right. So we will continue. Mark it complete and okay. Seriously, it's just hating me. Okay.
We are waiting for people to mark this as complete before the next button comes on.
Okay.
So when the majority of the people mark it, that's when the next button will come up.
Okay. Okay, now I see. Thank you for clarifying, Sonny. All right, so let's move next. Okay, so I have already introduced to you guys about the primitive data types. So it's like integer, float, string, and Boolean. But in Python, there's some kind of data structure that's already like built in for you guys to like use it for the objects. For example, it's going to be tuple, list, sets, and dictionary. For list and dictionary and tuples, you're going to use this a lot in machine learning. It's just like to referring around. And and to like, if you want to convert between all of them, just give it the type name and then the object you need to convert. Okay. For example, like if you want to, this is the syntax of a list, and if you want to convert it into a set, just say set parentheses and put the object inside, the variable inside. Okay. So let's move to tuple first. So what is tuple? Tuple is an ordered and immutable collection. By order, it means that you can access it by index, and by immutation, it means that you cannot change any element in it. The element that we will accept is any kind of data type. It can be integer, it can be float, it can be string, it can be even tuple itself. Yeah, and you can see here is the way that we define a tuple. You will use the parentheses to define it. So let's just put this one into the Collab notebook so that you guys can see how this one gonna work. I will move this a little bit bigger for you guys to see it. Oof, this is when you try to change it. Let's just comment this out for a bit and rerun this. So here in the tuple, you will see that the first element gonna be one is an integer. The second one is a tuple. The third one is a tuple as well. And the fourth one is a string. Inside it could be a mix of data types. You don't need to like strictly follow any kind of data types in here. And you can also like access it in a nested way. So it means that if this is the second one, and you can access like the first one of the second one and the second one of the second one, like this way, okay? Yeah, just think about it as like a multi-dimensional array. So you can use the index to access the first layer, the first dimension, and then use the second one to access the element inside of it, if it has. And one thing about Python is that you can not only like access from like forward, you can access backwards as well. So it means like if you want to access the last element, you can start with -1 and then -2, -3, -4. It still works the same. And yeah, to bring to the point that I said before about like how you cannot change the element of it. So you can see that if you try to change the second element of it to 3, it's not going to work. It will show you the error because it say that it's not going to support this kind of like change. All right, that is all about tuples. Any question about the tuples, you can just drop in the comment. Our officer will answer for you, and we will move along with the list. All right, for the list one, I don't like the error to showing up, so I just, yeah, you guys can always clear the output by like clicking to this X, so it will clear out all the output that you guys generate. Okay, for the list, so in here is an ordered one and immutable one. About the list, it's mutable. So it's totally like, it's pretty much the same to tuples, but the only difference that you can change the element in it. So instead of like using the parentheses, you will use a bracket here, and it will work this time when you try to change it. Let's see. So here's the list. You can see the same thing, same pattern on the tuples. You got a mix of data types here. If possible, you can access this with the index. You can access this backward. You can do the nested one. And when you change it, there was no error this like appear. The only thing with a list that you need to remember is because it will be mutable. So the way that it's worked like this. So in your memory is going to have like it will assign a place for you to refer to that object. And when you assign this object to other, like you got the X here, you declare it as a list here, and you say Y equal to X as well. This one gonna point to the same object. So it means that when you change X, you're gonna change Y as well. So you can see here that we only change the last element of X, but when we print out like both X and Y, it's also change Y as well. So this is a very common pitfall when you do like programming in Python, that you need to be very careful because like it will change any kind of other elements that assign to that list or that object. All right. So just be mindful about that when you use list. But otherwise, it's super cool and super convenient to do all the kind of like computations and refer data back and grab. All right. Yeah, this one is just another example for you guys to see about like the X and Y, because it's only changed one for the X, but it changed for the Y as well. All right. Okay, the next one is the set. So for the first two one is all ordered, which means that you can access with the index one. But for the set one is unordered, which means that you will not be able to predict most of the time how it's going to arrange or how it's going to appear. And this one is also a multiple collections, which means that you can add or delete any kind of like element in it. And the unique things about this one is you only have unique elements. So it's, for example, if you have like a list of number in this, and you want to change the set, and when you print this out, you will see that there will be in the original list, you will have like three number one, but when you change to set, it will automatically change just to one. You can just declare it with the curly brackets as well, but I just wanted to like perform the casting between like all kinds of structure type here so that you can see it, how it works. And you can see that all of the duplication of number one has already been removed. And yeah, and it also accepts like a mix of data types as well. And you can see that even if like if we do like 3, 2, 1 here, I think it will still show you like 1, 2, 3, 6 in like a kind of like ascending orders, but you will know like it will like reorder it itself, and we cannot like define like how it's going to appear. So that's why I say like unordered, because you can just like say that, hey, let's give me number one. It's not fixed like that. It will rearrange itself. And the last one, I will go through the dictionary and then I will get back to you guys to see if you guys have any kind of like questions, so just drop it in the chat and I will get back to you guys after this one. Dictionary is as the same way as set, is unordered and it multiple collection, but it's not about like unique elements anymore, but it's more about like key value pair. So it's pretty similar to the concept of like hash map, if you have already learned about that. And again, it's not going to be accessed by index, but it is accessed by key. So you're going to retrieve the key and you got the value corresponding to that. Any kind of elements can be works at the key or at the value. And its element can change. Okay, here is a very similar. Let's just do this one first. Let's see it. All right, so we have a school variable here. It's a string variable. I assign the value UTD to it, and then we can have like the key is a name, and then colon, and then DSC, assign the value to the key name. Number 2, assign the value to the key age. Most of the time I'm doing the string here at the key, but you can type anything as like it not need to be like uniform in the data types when it comes to keys and values. And yeah, it will not like this. It will not show most of the time like the way that we expected how it's gonna appear. And if you want to retrieve all the keys, just say dot keys in parentheses. If you want to retrieve all the values, just say dot values parentheses. So it will disappear. Oh, sorry. It will show every values and key corresponding in the dictionary. And to access or to modify values in the dictionary, you can just like access it using the bracket and the keys inside. Or the second way is you get, and then, sorry, here's the first one. When you want to access it, just use a bracket and then the key inside, or get one. The thing is about the get one and why I prefer it more is you can see that in here, it can be a typo. And if you put it in here like this, it's gonna give you an error, all right? But if you get is like a safe way to get access. So if your key doesn't exist, it will return you an alternative value that you assigned here. So if you want to know like, okay, if it's the key that really exists in my dictionary, I'm not sure, it will give you return you a very like safe way. But at the same time, it comes with another pitfall that you can have a typo here like me, and it will not return like what you say, but it just return the default one. All right. So yep, that should conclude our part for the structure types. I will go through the question again to see like if you guys had any question. Any question, you guys? I don't see much here, just pretty much for the most of it. Oh, so 0 is like the alternative value that you want to return if there is like no keys like that. For example, if you say, okay, so we have here for the keys, this can say like, if you want to get the name right, I will create a new one so it's easier to see. For example, in the student dictionary, if you want to know like what values attach to the key name, all right, it will return DSC, right? But let's say you somehow mistype it, it will return you an error. So get is a way to like let you return, or just like you want to know like, let's say, you want to know who is a advisor or something of the club, right? But this key doesn't exist in the dictionary that we declared first. And you want to know like, okay, if there is no advisor had been like set to the dictionary yet, you will use get, and then you give an alternative value. Okay, if you don't find this key in the dictionary, just say not assigned, all right? And it will return you this alternative value, all right? Okay, cool. Yeah, it's kind of like a safe way to like access the values in the dictionary. You could think about it like that. Okay, I will slow it down. Sorry, you guys. I'm just so passionate about this, so pardon me. That is a very interesting question. We can just print it out and we'll see. Nope, it just returned like an alternative one. It's not like actually change the dictionary. All right? It's just like, if you found it, return this. But if you not found it, just return like a default values to let it know like there is not exist in your dictionary. Very interesting. Let's see. What is the most use case I do for dictionary? Like most of the time when you want to search it up something very quickly, like in machine learning, when I try to, you know, like if you get familiar with the concept, like when you try to move in the forward progressions and you have to put some kind of variable in there to store like, okay, this is a coefficient that we want to this kind of like nodes in the neural network, you will have to put it in there to like store it and move forward. You want to like know like, okay, I can access this just by coefficient for node 1. What is it? It's just like a way for you, literally like its name, a dictionary, for you guys to search this up like, okay, what kind of value that I get from the previous node and I move it to the next node 1 when you go through the neural network. That's will be like the most of the time that I use for dictionary in machine learning. But for other one, it's got like super useful when you come for like search and just like parse data type and you want to assign some kind of like meaningful label for it. Yes, I can. Just say. It's weird. It's only. I guess this is all in the native library except for the random in the previous exercise. Do most Python IDE not require import of the standard library? Yeah, most of the time, like, it's only use some kind of like external library. Well, yeah, this one is like always is like built-in one. The random one is just some like built-in libraries that you can use most of the time. There will be a lot of like native libraries you can use, like OS and yeah, OS, random. It will be a lot. Like the most interesting about Python is that it got a lot of library for you, so that you can just like use it and you can just like play around with it. It's super helpful when it comes to machine learning, is because you will like, like when you come into the machine learning fields, there's a lot of like algorithms that you will not love. Well, I love to do it, but many people just not want to do like the whole thing from the scratch. So library is like a shortcut for you to use that. Also, the one thing about Python that I said is an interpret language, so that it will run really slow if you kind of like implement it from the scratch. But if you use some kind of like API, external API or libraries, it will let you to like run it with some kind of like native code in C or C++, run super fast, and then it can just got the Python wrapper for you to use it in Python. So it will be much more faster when it come to the machine learning. Okay, cool. Oh yeah, and sorry, I was kind of distracted when I saw this, like the question about the library. I think Mira asked about the question. Yeah, like Sony like already answered you in the chat. I'm so sorry, I got distracted so easily. So yeah, you can just like add this one, like the way you do with the array. Like let's say advisor now. And advisor is method Plank, Smith. Oops. Nope, it's not dictionary, sorry. Yep, and it will assign it. If you want to access it, just get rid of this and we'll return that. All right? Why not just use C++ for machine learning then? It will be a nightmare. No, it's not. Actually, like a lot of people do it in C++ and C because it's super fast. But the thing is that is like, if you guys already learned about C and C++, you can see that a lot of things going on there. And it's not like really beginner friendly, except when you like really understand about the concept of like pointers and then how to pass around things, because you have to do the memory allocation and the memory resource. So it kind of like exhausting if you want to do like everything from scratch. But yes, it's definitely a way like many people now is trying to do, because it's super like helpful in the performancing. Yeah, I must agree. All right. Are we guys good? I don't know. I just mark the complete and see if the next one. Nope, not yet.
We are gonna wait for everyone to do mark as complete before having the next button pop up.
Oh yeah, yeah. So you guys just mark completed if you guys are already done with the code and just move along. Okay, so I think it already pops up. So I get everyone mostly marked complete. We'll move to the conditional one. Yay! For anyone that was kind of like asked about if and else at the beginning of the workshop, here we are. It's very similar to like C++ and Java. So just if, else, and else if. Well, in the case of else if, I make the mistake a lot of times to put it as if, but it's gonna be elif like this, kind of a shortened way. But sometimes it just make me feel a little bit weird to like put this way. But yeah, that's the way it is in Python. And remember that they will need no like curly brackets to like a like signal a kind of code block or parentheses here. It was just like the conditions and then a colon. And then you can use the spacing here to like specify like, okay, this is the like a new code block. This is like a new one. You don't want to like put it like this. Oops, okay. I'm sorry. I thought this was an IDE. So let's try to like edit in here. But yeah, this is gonna be different from this one. All right. Well, this one is very different in the spacing, but I will do it here. Okay. So this one is kind of like marked like, okay, if you say here is like a block. All of these gonna be treated the same because it's the same indentation level. This one gonna be treated the same. Well, this if and elif and elif and else. This one will be treated the same because it's the same indentation level. That's why I'm saying I signify I emphasize at the beginning of the workshop that spacing and indentation matters, because if you put this outside, it's gonna be different. All right, and yeah, let's see. This is B. Let's see. Whoops. Okay. Yep, you can see that with the same indentation level, so with the same, and it's free now. There is no like curly bracket to mark it. And for the coding convention, it usually 4 space or 1 tab to mark the new level of indentation. All right, and please don't forget this one. This one is very small there, but I forget it many times, so it will give you an error. All right. I never use switch in Python. Huh. So I'm not sure about it. I will have to look it up, actually. Like most of the time I just use Ipsel, so. Oh, Alex answered there. All right. Thank you, Alex. All right. That is about if else. I think we're good. I just mark complete here and wait. Nope, everyone is still on it. Yes, for the convert one, it's very similar to the way when you convert between the structure type. Just specify the type at the beginning and then just use parentheses and put the variable or object inside of it. Oh no, Dylan is got left behind. Can anyone have Dylan and let me know if he successfully moved past the structure type? Can you try to reload it, or I don't know, move previous and then mark complete again, Dylan? Okay. All right, let's see. All right, the next button appears. So let's move to the last one. Okay, this is the last part of our basic syntax thing. So hopefully you guys still with me. The loops one. Okay, for loops, it only have while loop and for loop. In Python, there is no do while loops as far as I know. And for the while loop, you only use it when you're not like sure about how many times you want to execute the iteration. And for the for loop, yes, when you know like a definite number of times you already got a sense of it and you want to use it. It's pretty much similar to other language. So just like why, the condition, colon, and then indentation for any code block inside that you want to do it. let's just do it for the while loop. Let's just say here, loops. Oh, as you can see that the indentation error is here. So it's super weird when you kind of like mistype a space or something. It's not gonna like matter much when it's in like C++ and Java, but in Python, this is gonna happen a lot because like sometimes I just like type and then I just give it a space and it will show you some kind of indentation error. So just make sure that all of your code block is in the same indentation levels when it comes to like doing some loops or conditions or anything that you want to mark as a different code block. All right, and yes, it does column there, just the same way with everything else. And here's the for loop. For the for loop, it has some different way for you to loop through the for loop. It's not going to be similar to others programming language at the sense that you can already see in like C++ or Java. You can see that it's not going to have like a parentheses here, the condition, the condition, the test, and upgrade, all that part, no initializations, nope. In here is gonna have some variety of way to like loop through in the for loop. The first one is pretty much the same logic that we use normally is in range. So when you use range, mean like it's gonna go from 0 to less than 10. You can see it here. All right, it's pretty much like for parentheses integer I equals 0, semicolon, y less than 10, semicolon, y plus plus. That's the same way in C++, okay? But in here you just say range number and it will go from 0 to less than that number. And the set, you can already see we use a keyword in. For this keyword in, we can use range or we can use a list, which is you can access with some kind of like ordered collection. So you can see here like, okay, you can loop through like each of the values of elements in that list. Like it will print out all the store here, it's just not print out the number, right? It will say, okay, the first, oops, this is from the previous, so or the int, Starbucks, Chick-fil-A, the pub, Panda Express, it will loop through each of the elements and print out, all right? And more on the range, you can see that it's not just like, okay, I want it in range 10. You can actually specify like what initial values you want to do, what is the last value that it must be less than, and what is the step. This one is super similar to the C++ here, but it's just like very simplified, like oversimplified here. It's just like, okay, initial value, last one, and then the step. How many do you want to increment it, all right? So instead of like 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, it's just like 1, 3, 5, 7, 9, all right? And yeah, the last one is that when you see with the in list here, you only see the values of it print out, but you can also get the point, no, the iterator, but it comes with it. Like here, you can use a syntax as a enumerate. So for example, you can enumerate this list, so it will return you the iterator of it and the values corresponding to it. And you can print out both of them. For example, here you will print out like, okay, when you enumerate through the store, it will go through 0 for the ID and then Starbucks for the values. 1 for the ID, Chick-fil-A for the values, all right? And it was like just print it out as other usual for loops. One interesting about this enumerator is you can also specify what is the starting values. It just auto, like by default, it will start by 0. But if you specify another number here, like for example, I say 2 here, just enumerate the list or the kind of collection you want to loop through, and then you comma and use the starting values here. All right, you're gonna start at 2 and increment it to 6 until the end of the loop, yeah. So, all right, that is about the loops in Python. Is there anything? switch. All right, let's mark this. Yeah, I put some of my free resource for like you guys to dive deeper into Python, because I know that we're only here for like an hour and a half max. So there's a lot of like concept we cannot like dive deeper into it with you guys. So I will definitely like send some kind of free resource into the chat for you guys to like look it up and learn more. But yeah, this should be marked complete for the like the basic syntax that we have. And for the next part, we will have Brian to go through with you guys on functions and classes, so that you can understand more about the OOP part of this programming language. So if you guys still have any like question related to the basic syntax, the loops, the control flow, just put it in the chat and I will answer for you guys. All right. And I will leave the stage for Brian now. All right. See, yeah, well, Brian, can you?
Yeah.
I just hide my presenting stuff. So can you just like present it? I don't know how to stop now. All right.
Okay. Can y'all see this? All right, nice. So, hi everybody. My name is Brian. I'm a computer science sophomore, and I am the marketing lead for DSC. So today I'll be talking about Python's functions, files, as well as classes. So a function is basically a block of code that can be reused multiple times. And so the main reason that you want to use a function is so that you can increase the modularity of the code and keep yourself from copy and pasting your code too much. And so there's several inbuilt functions in Python. Evelyn already went through a few of them. One example is the print function. So if we copy this to the Collab, we can see that the print function takes in a string and then it prints it out to the standard output. And so let's break down what a function is. Here's an example of a valid function in Python. It has the function declaration, which is defined, and then you would add the name of the function, which is add nums, and then the two variables that you pass in here are called parameters. And so whenever you call the function and you pass in these variables, you can access the variables inside of the function. So if we have x and y, the colon shows that it tells the Python compiler that everything past the define that's indented will be part of the function. So then once we have x plus y, we have a function. Very nice, right? So let's try and run this. No errors, but it doesn't do anything. So one reason it doesn't do anything is because it doesn't have the return statement. And so right now, the code runs inside of this, but doesn't return anything outside. So one thing that we need to add, the return statement allows the function to basically send a variable or some type of data outside of the function. So once we have this, it should work, right? Let's run it. Still no errors, but it doesn't really do anything. That's because the return function, or it's because that we don't actually call the function. So right now we have the function, the declaration, as well as the code inside of the function, but we don't actually call it. And calling the function makes the function run the code inside of it. So here we have an example of calling the function. Basically, you would, outside of the function, call it as add nums, and then you pass in the parameters that you would like. So here I have 5 and 10, and then the return will return it to the print statement. So then this will print 5 and 10. For the, you can also use the return statement to assign the return to a variable. So since this will return a 5 or return 15, then it will assign 15 to z, and then you can print z through there. So now let's run. Nice. So this is a pretty simple example, and you can honestly just do like x plus y. But functions can definitely be as complex as you want it to be. And so here's a more complex example of a function. It's actually on LeetCode, which is running sum 1 for 80. I can paste the link in the chat. So basically, the running sum function goes through an array and it returns the sum of each element before the array. So if you pass in the array 1, 2, 3, and 4, it'll return 1, 3, 6, and 10. And here's a brief explanation about it. So we go in here, you can see that all the code inside of the function is run whenever you call the function and then print. So now I have a small exercise at the bottom, which is writing your own function to count the number of odd integers in a list. So I'll give everybody a second to do that, and if they have any questions. So yes, Python is a script, and so usually you want to define a main every code here, and then call the main at the end. All right, so now I'll go through the example. So yeah, right now we have the input, which is nums, and then the output, which would be the output should be the length of this, which is 1, 3, 5, and 21, or 3, 4. So define count. So here we have the definition. We define the next lines being a function name, and then the parameter being nums, which is an array of integers. Then we can iterate through the values in num, and then see if the value is odd. So that would be a modulus division. Nice. So then once we count, we iterate through the array, then we can just return the number of odds. So let's see if this works. Nice. That's one of the errors that Evelyn pointed out earlier. It has to be a double equals. There we go. Nice. So this is 4, and that should be the correct answer. Yes, so num mod 2, modulus division is basically the remainder. So any number mod 2, if it's odd, then it has a remainder of 1. If it's even, it has a remainder of 0. So not equal, the negation operator is exclamation mark. So that would be 4. And that would be true because 2 is not equal to 4. So once you're finished with this section, mark is completed, and then we can move on. Yes, so the colons, basically whenever you create the function and then you have the colon, it shows that the next indented lines of code will be part of the function. So for the for loop as well, the colon shows that the next indented lines will be part of that for loop. It's the same thing as a bracket in terms of if you were doing Java or C++. So one of the interesting things about functions is that in Python is that you can also return different types. So let's say that we have, well, basically you can have an if statement, and if it's odd, you could return a 1, and then if it's even, you could return, let's say you could return an array. And so that's one of the good things about Python is that functions can have different return types. All right, let's move on to the next section, which will be files. So as we discussed before, Python has inbuilt functions for creating, reading, as well as writing to files. And the open function has two parameters. The first one, which would be the name of the file, and the second one is what you want to do with the file. So you can have read, write, append, or create. So let's try creating a file and then writing to it. One of the good things is that the write function also has a, if the file does not exist, then it will automatically create it for you. So here I open the file and then save it to F, the variable F. Then I write the string and then close it. So now you can see right now, I haven't run the function yet, and there are no, there's no sample file. So if I run it and then refresh, it should be here. I was in the wrong directory. But yeah, so here we can see, if we click on it, that the sample file has the data that we put in. Let me create a new code thing. So you can, so now let's go back to that same file and then read into it. Now instead of writing, we're reading. And then we save the data inside of the file into text, and then we can print it out from there. So let's run that. And here you can see that we have the data here. One thing you can also do in the Python, is read files line by line. And that's basically just a simple for loop going through the file and then printing each line inside the file. And since we saved the one line into the first file, then it prints out only the first line. But if there were more lines, it would be spaced. And then lastly, the with statement starts a block of code that allows you to open and then exit the function without closing it. And so this is convenient in terms of saving the data. You can see here that if we try to read the F, which is a file outside of the open statement, it returns an error because the file has already been closed. So once you're done with the section, click mark as completed, and then we answer any questions. Okay, so you don't always have to close the file. Once the Python program ends, it will close it for you, basically. But closing it, it's definitely better for the memory. And then the open opens the, this will be the name of the file. And then whenever you open it, it goes to this file, check to see if it's there for write. If it's not there, then it'll create it, and then it will save it to the F. So the file can be, you can also work with CSV files. It's very common in terms of machine learning. In this case, we're just writing a string. So the file type that makes the most sense for our case would be a text file. So in this case, because the file isn't there and we're trying to write to it, then it automatically creates the file for us. But if we tried to read and the file wasn't there, then it will return an error. Yeah, just a reminder, if you have finished, please click the completed button. So the with basically creates a text, a code block where the file is only accessible inside of this area. So here, I read the text into a variable, but here I try to access it outside of this with. So once that happens, it returns an IO error because the file has already been closed whenever I leave this block. So if there are no more questions, let's go to the next part. So classes and objects. Classes are the foundation of object-oriented programming, and the class represents a new type of object, allowing instances of the type to be created. And it's a very powerful concept in terms of computer science. So here's an example of a class that I have created, and it is a cat. So instances of the cat will be of type cat. Here, inside of the class, you can have class variables as well as class methods. And so then whenever you create an instance of a class, these variables and these methods are all associated with that instance. So in terms of creating a class, it's very similar to a function, except in this case, we have class instead of PEF, and then there's no parentheses because you don't have any variables there. So here's how you create an instance of a class. And then we're going to assign that to Jeffries. Jeffries is a cat. We want to let him talk. We're going to change his age to 14, and then we're going to print his age. Nice. So here you can see that we'll go through the methods. Here we just have a simple print. And then here we have the change age. Whenever you create a class method, you have to pass in the self, which is referring to the object itself. And then you can also pass in different variables such as the new age that you want to add. And in this, whenever you call the actual method, you don't have to specify a self inside of the parentheses because you're calling the specific instances method. Here we change the instance's age. as well as in the birthday function where we add 1 to the age. So here's an example of accessing the member variables. Here we have we create another instance named Steve. We print the default age, which is 0, as specified here. We can change it into 10 and then make Steve 10 years old. Accessing the method functions is also very similar, where we, instead of just doing the age, which is no parentheses, we have the birthday function, which adds 1 to his age. And to call any function, any method, you have to add the parentheses, even if there is no parameter. So in the previous, we had Steve is 10. And now, after his birthday, he's 11. Remember to mark as completed once you're done with the session. Also, this is a very basic overview over classes, and they provide the structure for very powerful programming concepts such as inheritance, polymorphism, and abstraction. We won't go over those today because they can be very in-depth, but that's something that you will learn in introductory computer science class. Yes, Python does have constructors. So the default constructor in Python is init. So if we have this, don't mind my spelling, and then we can have all the code that's written here would be ran whenever you create an instance. So let's say that we pass in a 4, and that would be the first stage. Then you can do whatever you want inside of the init function, and that's run whenever you create the function, or create the instance of the class. Any more questions? Okay, let's move on. So now we will be working on libraries.
Okay, I guess I'll take over. Can you guys see? Can you guys see my screen? All right, perfect. Okay. So here we go. So we're in the last section of the Intro to Python workshop. I'm going to try to keep it short and sweet. So Brian and Evelyn did a great job of explaining a lot of concepts really quick. So good job to them. I'm going to try to keep that up and go over one of the important libraries in Python. So before I do that, let me just introduce myself really quick. My name is Abjay. I'm the event committee officer at DSC. I'm a sophomore in software engineering, and yeah, that's basically it about me. So let's get started. So the library I'm going to be talking about is Numpy. So Numpy is essentially just a Python library used for working with arrays. All right. So based on Evelyn's speech before, you guys learned that there's a thing called lists. And if you've learned any other object-oriented programming language before, you've obviously heard of arrays. So this library is just an expanded version of using lists. And there's actually benefits to using this over what Python provides to you. So for example, lists use it takes a lot longer to run. They use more space in the memory of your computer. So it takes more longer to run. And especially when you're trying to build a program that's supposed to be more efficient in an application, you would want it to run faster. And in those type of senses, you would want to use NumPy. A good way to put it is that NumPy is around 50 times faster than a list in Python. So I would prefer you guys use this over list. If you're creating a normal program, then by all means go ahead and use a list. But if you're creating something more complex, you would want to use NumPy. It's a fundamental scientific package for Python. So if you're working on any like data analysis, etc., you're going to be using NumPy. So I added so I'm pretty sure this is what a matrix looks like. So this is from linear algebra. I don't know if you guys have learned it, but basically what it is that this is how an array looks like if you visualize it. So if you create a two-dimensional array, it's literally going to be 2 columns and 2 rows, and it's going to have like coordinates. So for example, if you say row 1, column 1, then it's going to look at the value in that point. So when you create such large data sets, it's going to create a multi-dimensional array, and obviously that's going to require more functions. So you would rather use NumPy, as I already stated. So I'm not going to code along with you guys on this. I'm just going to go over it. I don't have a lot to code, so I'm just going to explain it. So can you guys see the thing on Track It? Yeah. Okay. So first, since this is a library, you would want to import it into Python, so into your project. So you're going to say import NumPy as NP. So this is going to go in the top of your project. You're simply just going to say this. So the import NumPy is going to import it, and as NP, the reason why you do this is that every time you mention NumPy, you don't want to be typing on NumPy. You rather just type NP. You rather keep it short, right? A good, like, this is not related to NumPy, but a good thing for coding itself is that you're coding to make life easier. So make it easier on yourself and just type it shorter, right? So try to find these nifty ways to make coding shorter and more efficient for yourself. So once you've imported it, now we'll go ahead and I'll show you how to use it. So I'm going to give you 2 examples. One is going to be a 1-dimensional array, and the other one's going to be a 2-dimensional array. These are just basic examples, but NumPy can obviously do a lot larger arrays than this. So a 1-dimensional array, it's simple. So you just create the variable name, and then you say np, which is NumPy, dot array. So you're creating an array. And inside the parentheses, you put square brackets, and you just list out all the values that you want in that array. And when you run this, and when you print it out, it just prints out the values. So you know that the values have been stored in the 1-dimensional array. Now I'm going to show you a 2-dimensional array. So this is a little bit more complex. In this one, you just say 2-dimensional array, np.array equal to, and then inside the parentheses, you create coordinates. So as I already stated previously, a 2-dimensional array and greater is going to have columns and rows. So you're basically just creating coordinates right here. So X and Y coordinates. So the X is going to be your rows, and then the Y is going to be your columns. So if you look right here, so if you create it, so you can see that 6, 5, 11, 7, 4, 8. And this is a 2-dimensional array. So if you want to look at it, this is just how you create it. And if you want to populate a matrix with all zeros, so for example, sometimes you're going to code in binary. And if you want to code in binary, you wouldn't want to waste your time entering zeros and ones. So you would rather just use a function like np.zeros, which is going to automatically fill your array with all zeros, or np.ones, which is going to fill your array with all ones and make it easier for you. So next, we're going to look at populating arrays with sequences of numbers. So once again, we're trying to make it easier. So instead of listing like 5, 6, 1, 2, 3, 4, 5 or something like that, right? You would rather have the computer list it out for you. You rather just give it a range and then expect it, like you rather just say 1, 4 and expect it to list all the values from 1 through 4, right? Like a loop. So you would say sequence of integers equal to np, we're calling NumPy, dot a range, a function in it. And you're saying that you want to list values from 5 through 12. And when you do this, if you print this, it simply prints 5, 6, 7, 8, 9, 10, 11. Remember that I think they already mentioned this previously. Remember that it only meets in programming itself, your lower bound is always met. So for example, the 5 is met, right? But then the 11, but then the 12 is not met. It's always one value less than 12. So it's always one value less than your upper bound. So it's going to be 11 on this, in this case scenario. So always keep that in the back of your mind. Like when you're new to programming, typically that's an error that a lot of people make. You keep forgetting about the upper bound, and you get different values. So another thing, random numbers. Sometimes you don't. When you're working on a project, you would just want, random values. You wouldn't know what you want off the top of your head. So when you're creating it, this is also easy. You just have to say random integers between 50 and 100. So we're going to create values between 50 and 100. I'm going to call numpy, and I'm going to say random.randint. So I'm saying that I want to create a random value, and I want to create a random integer. All right, so you got to specify that you want integers, right? And inside the parentheses, you're going to say the lower bound of the value is going to be 50, and the higher bound is going to be 101. And size is going to be a 6. So I'll explain to you what this does when I run it. So right here, it prints out a bunch of values. So the lower bound is 50, right? And the upper bound is going to be, hold up. Let me move on and track it. My bad. Okay, yeah. So this is where we're, it's not moving on anymore. Can you guys move on beyond this? Are you guys able to go on to the thing that I'm showing right here? All right, yeah, it's up now. Okay, so I think, yeah, we're here. Okay, so sorry for falling behind on that, but so basically here, we're creating random integers. So it's going to be between 50 and 101, right? So when you print it out, we have 6 values in the range of 50 to 101, and the size is 6, meaning we want 6 values. So once again, as I mentioned before, you got to be careful of the upper bound. So when you say that the upper bound is 101, the highest value that you could have in the random integers is going to be 100. If you want 101 in the range, then you have to say 102 as your upper bound. And then you'll be able to get 101 as one of your random integers. So just keep that on the back of your mind when you're working with arrays. So that's basically it. And then next, for creating a random floating point value between 0 and 1. So you typically use 0 and 1 if you're working with percentages. And this is a good thing to know when you're starting. So you would say something like random values between 0, random floats between 0 and 1. And you would say np numpy.random.random. You just call random twice. And then inside the parentheses and brackets, you say 6. So we want 6 values. And when you run this, you get 6 values that are in between 0 and 1. And typically, you know that these work as percentages, so they're used a lot in probability. And it's a good feature to have in your tool set. Next, we're going to go over mathematical operations. So this one's just going to be, arithmetic operations like adding, multiplying, or like, basic math. So here we're going to say random floats between 2 and 3. So we have this variable called random floats between 2 and 3. And we already created a variable called random floats between 0 and 1 right here. And we already have 6 values. And we're just saying +2. I'm pretty sure you can guess what's going to happen when I run this. So when I run it, it's just adding 2, the number 2, to all of the values in random floats between 0 and 1. And this is a simple operation that you could use. And same thing, I'm going to show you another example, except in multiplication. So here, I'm saying random integers between 150 and 300. And I already declared a variable called random integers between 50 and 100 up here. And we already have 6 values, right? So if I multiply by 3, it's just going to multiply all 6 values by 3, and you're going to get this new set. Now, the last part, this is going into a little bit more into like ML, machine learning. So I don't want to delve too deep into it. But basically, when you're working with data sets, you're going to have features and labels. And features are typically the x coordinate, and labels are the y coordinate. So when you're working on, like, for example, when you're teaching a machine, or even if you're teaching yourself, right? You're going to give yourself an example, and then after that, you're going to expect yourself to solve. Someone do 2 plus 2, they won't be able to do it. You always expect someone to go ahead and say, you give them an example. You're like, 1 plus 1 is 2. Now you do 2 plus 2 and give me the answer to that. And that's basically like how machine learning works. You give it an example, and then you expect it to do the same thing that you did. And that's what data sets are used for, right? So data sets are information, like examples that you pass into your computer, and you expect it to kind of be the example. And once the computer, you give it like an algorithm or like a formula, and you expect it to figure it out, and you expect it to like predict data when you give it new data. I know it's kind of confusing, but you just give it a data set and etc. So here, we're creating a linear data set. A linear data set is just like y equal to mx plus b, right? You guys know basic algebra. So when you're creating a line, like a linear regression model, you learn that in the future. This is basically like a formula that you would use. So the label, as I mentioned, is going to be your y value, and the feature is going to be your x value. You're just going to create a formula that's going to say label equal to 3, feature plus 4. So think of this as a formula or like an algorithm that you're using for your project. If you pass in a feature value of 6, it's going to multiply 3 times 6 is 18 plus 4, 22. So you get a label value. So it's kind of confusing right now, like what this has to do with NumPy. But basically, once you start applying this with machine learning, you're going to understand it a lot better than how I put it right now. But hopefully you can use these basic code that I've given to you and everything else that we've done previously, and you could create something with it. So that's all I have for this. So thank you. Unless you have any questions.
Okay. Thanks, Abhijay. So
yeah.
I guess this is going to end the first part of our Explore ML series. Once again, if you have any questions, put them in the Discord. And we would really like if you do a post workshop survey so that we can know what things we did correct, what things we did not so well. And that'll help us in order to improve for next several workshops. So yeah, thank you very much for coming.
We'll be sending you all the post survey link in the email,
yeah.
And we'll also be dropping that in the Discord. And whenever you want to come back to access this materials, they'll always be available on Track IT. And in a few hours, we'll also put up all these files on GitHub in this link, so you can go and view them. Next week, we have our Explore ML workshop where you learn more, where you would learn about some more Python libraries and about some classification and regression. You can RSVP for that in the link on Track IT, and we'll send that out too. And do join our social media platforms for DSC and ACM. We have Discords, and we also have our mailing list links. And thank you all for coming, and a huge shout out to the officers of both DSC and ACM for organizing this.
Yep. So and thanks for coming. And in case you want to review the workshop later, you can. And you can also ask questions in the Discord. We'll still have, I guess, the Intro to Python event channel up, so you can ask questions there, and people will answer you. So yeah, and thanks very much for coming, and hope you have a great weekend.